Good morning, everyone. My name is Osehi, and I'm one of the new senior economics tutors for OneClass. And today, I'm going to be going over a couple of economics questions. And how it's going to work is our junior tutors have answered some of these questions, and I'm just going to take you through the thought process of how they arrived at these answers. First of all, a little background of me is I have a bachelor's degree in economics from Osehi University, and I currently work as an analyst for one of the big five banks in Canada. So, with all that being said, let's get started and take a look at some of these questions. Okay, so the first question is good will tend to be more price elastic if it A is a luxury good, B has no close substitutes, C is a small part of the household budget, D is a necessity. And let's see what one of our junior tutors answered. And they said when 1% change in price results in a more than 1% change in quantity demanded, the good has price elastic demand. So the answer is a luxury good is price elastic because if you lower the price of a good, demand will increase more. When the price of the luxury good increases, the demand for luxury goods will decrease more proportionately. Sports cars are an example of a luxury good with price elastic demand. All other items in the list have an elastic price elasticity of demand, and therefore the answer is A, it's a luxury good. So I do agree with this answer, and let's just take a look at all the other options. So if a B says the good has no close substitutes, and it would have, based on our definition of price elastic demand, a 1% change results in a more than 1% change in quantity demanded. B would make no sense because if a good has no close substitutes, then you can't really replace it with too many other things. So little increase in price won't necessarily have that huge an effect on demand. Option C says it's a small part of the household budget, and again, if it's just a small part of the household budget, then you need it in order to deal with your household, and basically 1% little change in price shouldn't affect that either. And D, if it's a necessity, for example, water. We need water to survive, so basically change in price for water it might make customers more hesitant, but you'll realize you need it to survive, so shouldn't really affect the quantity demanded either. So I do agree a luxury good is the correct answer for this one. So I'll go ahead and verify that. Explanation spelled that correctly. Okay, so next question. This is question 2. And it says the price elasticity of demand equals 0.2. So we could just write that. We'll denote that as PE, price elasticity, or PED, price elasticity of demand, equals 0.12. And the current price for a pack of cigarettes is $2. So we know our price equals $2. If we were to decrease smoking by 20%, what should the new price of cigarettes become? So basically, decrease in smoking basically also means decrease in consumption of cigarettes. So we could say the change in quantity demand, change in QD equals 20%. So the question is, what is the new price of the pack of cigarettes? And let's see what our junior tutor said here. Given the price elasticity of demand is 0.2 and the current price of cigarettes is $2, given. If we wish to decrease smoking by 20%, we have a percentage change in quantity demanded of 20%. And from the elasticity rule, we know that elasticity of demand equals change in quantity demanded over change in price. So our equation for elasticity of demand, we'll just call it E, equals change, percent change. So I can just put a little percentage sign here to show it's a percent change in quantity demand over percent change in price, or change in price. So now it's just about plugging things in here, and let's see what they did. They said elasticity of demand is negative 0.12. Again, the signs don't really matter when it comes to dealing with elasticity of demand. So if you put a negative or not, your final answer is always going to be a positive number. So we'll say E equals, oh, I forgot to put the decimal over here. Okay, let's say E equals 0.2 equals the percent change in quantity demand is 20% over change in price. And they said here, they did the math, and percent change in price equals 20% over 0.2 equals 100%. Hence, the price should increase by 100% from $2 to $2 plus whatever 100% multiplied by 2 is, which is 2, and that's 4. So I agree with this, and let's just finish our little math over here. So change things, change in price equals 20% over 0.2. We know that's 100%. So, and the price is 2, and 100% of 2 is also 2. The new price is $4. So I also agree with this, and we'll just go ahead and verify that solution. So the new price of the pack of cigarettes would be $4, and this also relates to like basic supply and demand, where if demand goes down, if the price goes up, demand goes down, and for the supply curve, the price goes up, supply goes up. So we'll say correct, great explanation, and solution is correct. Okay, let's erase this. Oh, just a little more. Okay, so next question. This is question number 3. The labor supply curve slopes upward if leisure is a normal good, consumption is a normal good. The income effect on leisure is greater than the substitution effect, and substitution effect on leisure is greater than income. So those are all our options. And see what the junior tutor said here. They said D, the substitution effect is greater than the income. Refer to the graph below. The labor supply curve is downward sloping at lower wages, but in higher wages the curve becomes upward sloping. Lower wages, substitution effect is greater than the income effect, where changes in labor supply are results of changes in wages. Given the situation, people who are earning lower wages tend to work than to spend their time in leisure. So let's look at this graph. This graph is actually perfect, and it's a perfect way to explain this question. So let's draw one. So we know this is wages, and this is unit of labor, because I'm not going to write out the unit of labor, so we'll just call this L for labor. And graph basically looks something like this. And so denote IE for income effect greater than SE for substitution effect, and SE greater than IE. So again, this graph is correct, but let's just go through this explanation again. So the substitution effect is greater than, on leisure, is greater than the income effect. So the question is asking if the labor curve is sloped upwards, what is going on? And basically sloping upwards, we know that means just sloping upwards over here, that portion of the graph. And it is true that the substitution effect on leisure is greater than income, but to explain it even further, it's basically saying that you have a desired income. Everyone has a desired income in which they want to make, and as wages go up, the closer you are to achieving that desired income. So we'll call this point over here the equilibrium, and when you reach that, that's basically your desired income. So if the graph is upward sloping, that means as long as wage increases up until this point where it stops being sloping, your substitution effect is greater than your income effect, because you would rather work than spend time doing leisure activities. And then once it goes over, so once it becomes downward sloping, it means that like your wage is high enough and you could actually afford to spend some more time doing leisure than work, because you're already achieving that income that you want to achieve. You're already achieving your desired income at one of the wages over here. So because when the slope is upward sloping, you haven't really achieved that desired income. You would rather work, spend more hours working, so labor keeps on going up, and your wages will also continue to go up until you reach that desired income. So because it's upward sloping, then the substitution effect on leisure is greater than the income effect, and you would rather continue to work than to spend more time with leisure. So I do agree with this answer over here, and that was just my brief little explanation. So we'll comment on that. Correct. Good explanation. the fact that they included the graph, so we'll just comment on that also. Okay, what's the next question? Okay, let's take out what we drew over here. If the marginal propensity to consume is 0.75, then A, the marginal propensity to save is 0.75. B, the marginal propensity to save is 1.33. C, the marginal propensity to save is 0.20. And D, the marginal propensity to save is equal to 0.25. So this is question 4, I believe. Right off the bat, it's talking about marginal propensity to consume and marginal propensity to save. Before we even look at this, there's a specific way I'd like to look at this specific question when it deals with marginal propensity to save and marginal propensity to consume. And it's basically let's say you receive $100, you only have 2 options you could do with that. You could spend it, or you could save it. So basically you could spend a portion of it, if not all of it, or you could also save a portion of it. And yeah, so basically, since there's only 2 things you could do there, those 2 options that you make equals basically 100% of the decisions possible. So if you could divide it into 50-50 for, we'll call this NPC, and this is the other 50%. Let's just erase that. This is the other 50%. Ooh. What's going on? There we go. This is, wow, okay. Let's just try it this way. This is the other 50%. And we'll call this MPS equals 100%. Put that in decimals, it's 0.5 plus 0.5 equals 1. So basically, from this you could tell that whatever your marginal propensity to consume is, it's an awkward looking P, made it even more awkward, but that's not the point. So whatever your marginal propensity to consume is, whether it's 0.3, 0.5, 0.6, their marginal propensity to save will make that marginal propensity to consume equals 1. So if it's 0.5, 1 minus 0.5 will give you another 0.5. So if your marginal propensity to consume is 50%, marginal propensity to save will also be 50%. So looking at this question over here, if we write down the equation as MPS plus MPC equals 1, then just fill in the blanks over here. We don't know what we're looking for. MPS over here, so we'll just leave a question mark, plus 0.75 because it tells us what the marginal propensity to consume is, equals 1. Then basically MPS equals 1 minus 0.75 equals 0.25, and that should be our answer. So the answer should be D. Marginal propensity to save is 0.25. Let's see what our junior tutor said, and it looks like they said the exact same thing. Marginal propensity to consume is 0.75. Then the marginal propensity to save is 0.25. The equation showing the relationship between marginal propensity to consume and marginal propensity to save is MPC plus MPS equals 1, like we showed over here. Therefore, it follows MPS equals 1 minus MPC equals 1 minus 0.75 equals 0.25. And that is the right answer. So the right answer is D. Correct. Great explanation. And let's move on to the next question. So this is question, ooh, it's upside down. This is question 5. And define marginal cost. Okay, so marginal cost is the change in total cost by increasing the production of a new unit. The change in total cost by increasing the production of a new unit is called marginal cost. For example, if a company is establishing a new factory to produce more goods, the cost of establishment is known as marginal cost. So yeah, this is the correct answer. Could have had a different explanation, but I'll show an explanation over here. But let's take the first part. The change in total cost by increasing the production of a new unit is called marginal cost. So we could also make a little graph over here. Actually, the explanation is also, it's really good. And that is the definition of marginal cost. I just wanted to add this over here just to give you what it looks like with numbers and on a graph. So we'll call this Q for quantity, call this P for price, call this total cost, and call this marginal cost. And Q is, say, it's 1, 2, 3, 4, and this is price is 2. Uh, 4, 6, 8. So I'll just put a 0 over here. Your total cost here is 0. Total cost here is 2. Total cost here is 8. This is just multiplying price by quantity, by the way. Total cost here is 18, and total cost here is 24. No, it's not. I'm joking. It's 32. So your total cost here is 32. And basically the marginal cost is also the difference between the total cost when you increase production, or when you increase, I guess, when you increase production. So this is the cost of, price here is the cost of production. Here, quantity is the quantity of goods produced. And this is total cost, quantity minus price. And marginal cost is also, like they said here, the cost you incur when you increase production. So marginal cost here is 0. For producing one good, the marginal cost is also the same as the total cost, which is 2. For producing the second good, marginal cost will now be 8 minus 2, so the difference in the total cost, which is 6. And for the third, this will be 10 because it's 18 minus 8. And for the last one, it's gonna be 14 because it's 32 minus 18. So this is just another graphical representation of marginal cost. But like they said here, it's a total change. It's a change in total cost by increasing the production of a new unit. And yeah, so this is the change in total cost once you increase the production of a new unit. So we'll say this is correct. Let me do it for time. And this is question 6. So identify a good or service that is rivalrous and excludable. And how does the good or service meet both these requirements? Now name a good or service that is non-rivalrous and non-excludable. How does the good meet both these requirements? And goods and services that show both features of rivalry and excludability are private goods. So let's just give a brief explanation of rival. Rival good equals a good that could only, be consumed by one person, and a rivalrous good, an excludable good equals a person can be stopped from, it's an awkward F, just fix that up a little bit. Yikes. From consuming the good. So that's the definition of a private good. And if it's non-rival and non-excludable, which is the opposite of these two, that would be a public good. So excludability means preventing people from consuming the good. For example, in a way you could prevent someone from consuming is if they haven't paid for it. So a private good could be food, clothing, or cars, which are excludable in nature. And if a person does not pay for a cup of coffee, he or she is not allowed to have a cup of coffee. Whereas a person who has been paid receives the service. So these are just examples of excludable goods. And on the other hand, rivalry means if consumption by one consumer prevents simultaneous consumption from another. As for example, if I eat an apple, the same apple cannot be consumed at the same time by another person. If I use a pen, same pen cannot be used by another person at the same time. So all these here are examples of private goods. So food, clothing, cars. If you're using it, someone else cannot be using or eating the food at the same time. And you need to pay for those goods, so others can be stopped from consuming it if they don't pay for the good. And goods that are non-rivalrous and non-excludable are public goods. For example, national defense, air, and public parks. National defense is for all the citizens of the country. If a person has benefited from national defense, the same benefits cannot be limited to another citizen. So it's non-rival. And even if a person is not paying taxes to the government, the person can also enjoy national defense services. So again, that also meets the criteria of non-excludable. So therefore, national defense is a perfect example of a public good. So these are all good explanations. So we'll say correct. Ooh. So we'll say correct. And that was basically the last question I had. And that was pretty much it. So I'd like to thank you for tuning into this stream, and I'm looking forward to streaming in the future. Thank you. I'll stop stream.